In this lesson, I'm going to talk about diffuse ray depth. As we know, sample settings control the quality of our render, and we use it to remove noise from our different ray types. Ray depth settings control how far a ray can pass in our scene, how many times a ray can bounce in the scene. Now, as you can see in the ray depth section, we have diffuse, glossy, reflection, refraction, volume, and transparency. In this lesson, we're obviously going to talk about the diffuse ray depth. Diffuse ray depth controls the number of GI diffuse bounces. Now, this is the scene we are going to be working on for this lesson. I borrowed it from Cinema 4D's Canon browser and deleted most of the furniture so we can deal with simpler situation. I also added these two cubes in the middle of the room so I can explain diffuse ray depth a bit better. As you can see, I have this physical sky that illuminates the scene. We have the sun shining through this window, and everything has this default Arnold shader material applied onto. At the moment, we have our diffuse sample set to 2 and our diffuse ray depth set to 1, and this is the render we get based on these settings. Okay. Now let me close my picture viewer and let's zero out our diffuse ray depth and enable IPR. By doing so, we are basically limiting our direct light rays to have any sort of secondary bounces. So that is why if you take a look at the area where direct light can't reach, for example, the ceiling, the wall that has the window, this secondary wall here, the right wall, even this very small cube that we have here, we can't see it because a direct light can't reach to those areas, and because we limited our light rays to have any GI diffuse bounces. So they are basically black. As soon as I increase my diffuse ray depth to 1, we introduce GI diffuse bounce to our scene, and we are allowing our direct light rays to bounce one more time. And as you can see from the IPR, those dark walls and areas are now brighter. Let's open up Picture Viewer and quickly compare this render with the previous one. The first render, as you can see, we have no GI diffuse bounce and we have those very dark areas. In the second render, we have one diffuse ray depth and we are allowing our direct light ray to bounce one time. So a light ray hits a surface. When basically a light ray hits a surface, it won't be killed off there. It bounces from that surface and illuminates another surface with smaller amount of energy and illumination when it hits it, basically. That's why those previously dark areas are getting brighter here. Now, if I go to my render setting and increase my diffuse ray depth to 2, we are going to make those dark areas even brighter, because we are letting our light rays to bounce more in the scene and travel between surfaces. Now let's increase our diffuse ray depth to 2, and this is the result we are gonna get. The scene is brighter. Take a look at the baseboard corner now. It's much brighter and we can see more detail, and if you look closely you can see these differences all over the place. Now let's increase our diffuse ray depth to 3 and see what's gonna happen. So this is the render we have. The scene is brighter, but I can't see much improvements in the dark areas, and at the same time we have gone from 53 seconds for the previous render to 1 minute and 21 seconds for this render. So remember, as you increase your diffuse ray depth, you are increasing your render time. So I think for this render, 2 diffuse ray depth is going to be enough. One thing also I hope you noticed is the fact that even though we are increasing our GI diffuse ray depth, the noise is still there. Ray depth has nothing to do with quality and noise. If we wanted to get rid of the GI diffuse noise, we need to increase our diffuse samples so let me, for the final render here, increase my diffuse and camera samples to about 4 and decrease the diffuse ray depth to the previous, that was 2, and my physical sky samples to also around 3. And let's take a look at the render with these settings. So this is gonna be the results. It's much clearer, but still not quite perfect. We can go ahead and increase our diffuse samples a bit more, but I think this is gonna be enough for this tutorial. You can do it on your own time and see what setting can give you a perfect noise-free render, but I think this is enough for the moment. So remember, diffuse samples increases the quality and removes the noises, and diffuse ray depths basically allows the light rays to bounce in the scene, and the amount of the bounces will be controlled by the diffuser, and there is no relationship between the diffuse samples and the camera samples and the diffuse ray depths. It's not like the diffuse samples, when we increase the camera samples, diffuse samples also would increase, but here it has nothing to do with the camera samples. You increase it and it's completely independent from the camera samples. Diffuse ray depth is completely independent. So basically in this lesson we covered diffuse ray depth, and in the next lesson we discuss glossy and reflection ray depth. So see you there.